Today we're talking the ADK, Wiz. We're talking Google's Agent Development Kit. Now, they took a long time to sort of come out with this thing. So the expectation is that they looked at what everybody else was doing and they sort of brought all the good stuff in and they created like a really kind of nice, robust framework, right?
I mean, yes. I mean, that's what happened. It feels like that. It seems like that. Looks like that. There you go.
Okay. All right. So we looked at the Agents SDK from OpenAI recently. That was another one that sort of took a long time to come out. We said that one was pretty good. This one looks like it's pretty good too. And the docs are robust. That's for sure.
The docs are fire. Yeah.
We've got a great build for today. They've got some interesting ideas too. They've almost gone up a level of abstraction is the way that I'm thinking about this with some of their constructs that they're using that we'll go into. But, you know, I'm really excited about kind of this next layer of abstraction that we are now able to build out super easily. Again, it's not low code, but it is feeling like we're sort of going up a level a bit. Does it feel like that to you?
I think it feels like I wouldn't say up a level, but it definitely feels like we're entering some kind of maturity here, right?
Right.
We're locking some patterns down. We're really taking advantage of the agents are just loops, you know, meme. I think this is forward progress.
Agreed. All right. So for today, we're going to go through the few core concepts. We'll get into the code pretty quickly. We'll also discuss how this kind of compares to other frameworks and how we can think about using some of the latest protocols with an orchestration framework like ADK. You ready to get into it, Wiz?
I am so ready to get into it.
All right, let's go ahead and kick it off, everybody. Please go ahead and like and subscribe for weekly building, shipping, and sharing with the latest frameworks and tools. And if you've got questions along the way, don't hesitate to ask them live directly in the YouTube chat. We'll be monitoring during each discussion point as we go through each of the pieces that we need to really form the entire ADK puzzle. So let's go ahead and kick off Agent Development Kit from Google. So they're coming out fully open source. It's not exactly TensorFlow, but it's pretty good. And today what we want to do is we want to kind of align our aim. What are you going to get out of this session? Well, you're going to understand how ADK uses their idea of this event loop. We've talked a lot about event-driven versus maybe graph-based or graph traversal algorithm frameworks on here. But this event loop idea is kind of the heartbeat, as they say, of this framework. What does it mean? How does it connect to some of the things that we know about agents already? We're going to find out. We're going to take a look at a few of the key constructs, including agent and tool types, before we build, ship, and share our own multi-agent application. We've got kind of a fun dice rolling application we've built out using their tutorial that Wiz is going to walk us through. And then we're going to discuss and think about how we can actually leverage a framework like ADK with some of the emerging protocols, how we should think about doing that, and how this might connect to other events like the one that we're doing next week, which is going to be a much deeper dive on agent to agent protocol. So let's talk about ADK. Let's see what the kind of stuff they're putting out looks like before we get into the event loop and some of the core things that we're going to need to build, ship, and share our application today. Okay. Came out, this was April, early April. So last month, Agent Development Kit was announced. New open source framework. We're going to change the game, full stack, end to end. And interestingly, this is the same framework powering agents within Google. They came out and they said, okay, we've got 4 pillars: build, interact, evaluate, deploy. Well, if you know anything about our channel, we're always talking about build and evaluate, build and evaluate. This is a key pattern that you just have got to get comfortable with over and over, no matter what you're doing in AI engineering. And so this idea of these core pillars is pretty standard. You know, quote from their release blog. The core idea is Pythonic simplicity when it comes to the builds. And, we can look at simple examples where we're defining some agent logic. We're giving it access to some tools. We're telling it what we want it to do. This is not going to highlight the power of ADK well over anything else. And comparing these frameworks is getting harder and harder as they reach some sort of feature parity. So, disclaimer here that they provide for us, it's not really shining yet. We got to see some complexity before we can see some shine. So build, interact. They want you to have really flexible ways to interact. And this is kind of cool to see. So, we're able to interact through the command line, through a web UI, directly through API calls, or we can actually set up an API server. And so, they're kind of building out, the standard that they have seen and are trying to kind of continue to establish. We're starting to see, again, some sort of glimpses of maturity here when we get lots of different options for the way we might do things. When we talk about evaluating, they're sort of out of the box trying to help us evaluate final response quality and step-by-step execution trajectory. So this is kind of like the traces when you're doing runs. What's the logic? What's the reasoning pathway? What actions are being taken? What's failing? What has errors? Important in monitoring, important in logging. And then when we go to deployment, of course, they're going to, out of the box work with the Google stack. So, but they also work with other things too. Of course, if you're a GCP user, this might be a lot more attractive to you than if you're not. If you're leveraging Vertex AI often, or you're leveraging some of the CSP, more general CSP tools within GCP, maybe it's going to be a lot more attractive to you. But you can also sort of host anywhere. And this is kind of, I think, where open source users like us and like many of you are going to be more interested. So, okay, it works anywhere, but obviously it's optimized for Google Cloud. So we have this kind of core pattern. It's very marketing-y. We should be doing this kind of thing. Now, the kind of new thing, as far as I can tell, is they're trying to sort of brand this kind of event loop. And of course, we've seen, everywhere right now, we're seeing this kind of thing, in industry. And shout out to Hugging Face, I think, for cartoonizing this and immortalizing it perhaps. But like this idea of the agents just being a for loop, it's kind of a meme, but it's also kind of true. Well, when we talk about the event loop in ADK, we wanted to sort of think about the importance of events within the agent development kit first and foremost. It's sort of the fundamental unit. And the event is just sort of providing you with a specific point in the agent's execution. So we're going to sort of capture everything. We're going to sort of make sure that we're keeping track of each of these pieces: messages, replies, requests, tool results and calls, state changes, control signals and errors. So it's kind of very, very similar to this idea of just tracking state that we've talked about so much on the channel. And the event loop, it kind of looks like this. And here's how it goes. We've got kind of the user asking, hey, can you help me with something here? And then the runner, the runner is basically receiving that user query, and it asks the main agent, this execution logic, this is where kind of the agent lives, to start processing. That main agent is going to do some processing. It's going to be like, okay, well, let me see. Let me check out all the logic I'm supposed to go through. Let me do some stuff, maybe call some tools, maybe, make sure, let me get you back kind of what you're asking me for. And then I'm going to sort of emit this response. I'm going to yield this event back to the runner. And the runner is then going to like make sure everything's all good with tracking the session, tracking the conversation thread, tracking the state of affairs, what's happening. And, only sort of after the runner has processed the stuff coming back from the agent, from this execution logic, and kind of situating everything properly, storing everything properly, tracking that event and that state properly, then we're going to echo what we see back out. Okay? So one of the interesting things here is like, are we going to be able to just loop around inside kind of silently a whole bunch, loop around in here without emitting anything back out to the user? Not really. No, we're going to be popping back out, kind of like when you watch the reasoning model kind of work through step by step what it's thinking. But you're going to potentially need to go through multiple loops. So you might actually come back, go through another loop. You might then do this a few times before you ultimately yield some final output that you're going to stream back to the user. So like, will we do multiple loops inside without user intervention? Yes, but we're going to continue to sort of echo the things that we're processing, the reasoning, the actions, the core things that make an agent an agent. We're going to make sure that those are being made clear to the user. And so we've often conceptualized agents on this channel in a very simple way, where we ask a question, we go to the agent's going to take some sort of action that is going to be fed back to the agent. Maybe that's enough to provide a final answer, a final response. The types of actions we're taking are typically calling tools or simple functions. And the results from those tool calls are the things that we're going to observe and kind of pump back into the conversation and this thread. This react pattern of reasoning and action, where we're kind of updating our plans and reasoning through what we should do next, and then taking action by hitting an API or hitting a tool or hitting a function. This is kind of fundamental. Now, what we're doing here when we introduce this idea of the runner, when we introduce this idea of the event loop, is we're kind of putting this runner kind of in front of the agent. And so the runner is kind of being, again, this kind of going up a level of abstraction here. We're kind of giving this additional orchestration layer some power over the way this is kind of operating under the hood, so to speak. And we can think about that execution logic as all happening in this agent action sort of interaction. And then if we want to kind of think about the event loop itself, it's kind of contained within this 3-step. And the runner is kind of the spot where we're tracking the state, we're tracking the conversation thread, it's doing the coordination, it's initiating things, it's kicking off the event, it's receiving and processing stuff, and it's sort of, it's kind of the manager, a little bit of what's going on here. And so that's kind of a next level thing. It's kind of a little bit more, a little bit more abstracted, maybe a little bit easier to get started with. And this idea of the main entry point and, chief orchestrator for your query. It's going to kind of sit in front of all the stuff that's happening under the hood. So, this runner that essentially drives the conversation turn by turn allows us to think about this idea of kind of having gone up a level. So, Wiz, I wonder if you've got some comments on this. Like, how novel is this to put this runner in front of our execution logic? And is this the kind of thing that we expect from all frameworks, moving forward here? What's your take?
Yeah, I mean, they all do this. So this is like, this is the Lang graph. When you invoke the graph, right? What you're basically doing is moving through this, same pattern. Llama Index does this rather explicitly. The way we run agents, like when we call .invoke, that's what we're doing, right?
Oh,
And I think
okay.
this is a great pattern. I'm happy people are continuing to use it. I think this is a good implementation of it, right? But the idea is that it's basically what we're used to, which is good because what we're used to is worked quite well, up to this point. So
Yeah. Okay. So it's really not that different than anything we've seen before. Maybe they're just sort of conceptualizing it a little bit different in the way they present it to people at a high level.
yeah, I think it's very well detailed in the actual documentation, which is not typically something we've seen, right? So, famously, like documentation for these services is quite poor, and this is slightly less poor. And I think one of the things that's important is we're going to we're going to have this idea with all of the other agent frameworks. It's just nice to see them like draw a nice graph too.
Yeah, it's so good. The beautiful little visualization really does add something. I want to go take some questions from the chat here. So Richard Gower asks, can the runner run multiple event loops async and then consolidate responses? Is that the right way to think about this?
I don't know if that's the right way to think about this. Basically, the runtime, which is this where the runner is running, right? The runtime is I don't believe happy to have multiple runners, though you can of course set up simultaneous runtimes, and with things like A to A or otherwise you can communicate between these runtimes. But my understanding is that there is an event loop, literally as in the Python event loop, and the runner is running inside that event loop, right? So I would say yes, you can do that, but no, it's not like we have one runtime with many different runners
Okay.
inside it.
Okay. And Anthony Chapman asks, how is the runner different from a supervisor agent? This does kind of feel a little bit similar when we talk about orchestrating or managing kind of what's happening here.
Yeah, so very, very critically, this is actually totally different from the actual agent logic entirely. So what I mean by that is that your runner is basically this. It's just like the way you would think about the actual place and how we're running through our agent and code. But the agent, right, or that supervised agent, whatever it happens, it doesn't matter, right? Whatever version of agent you have, that's going to be separate to this process. So that's what's being run by the runner. So instead of thinking about it like this is some kind of supervisor for the agent application, this is kind of like a supervisor for the actual events that are occurring whilst you are doing agentic workflows. This does have some advantage over some other frameworks like OpenAI's framework and things like this. But like Llama Index and LangGraph both have the equivalent of this process. And this is, just it's really well spelled out here is the idea. Yeah. But it's I want to make sure we're clear. It's very distinct. Like the runtime is very distinct from the actual like agent logic or agent things that are happening. It's like a piece that sits on top of that flow that lets us interact with it through these events. So if you think about it as like the runtime or the sandbox, it's not a sandbox, but like let's just use that language for a second, that the agent is running in. That's the way you should be thinking about it. It's distinct though from the actual agent itself.
Yeah. Okay. And as we'll see, there's actually this concept of a root agent in ADK that maybe is more akin to this idea of a supervisor.
Yeah.
Okay. All right. Thanks, Wiz. Let's go ahead and introduce some idea of the agent types we can see and see how this matches up to things that we've seen in the past. So there are 3 different types: LLM-based, kind of non-LLM-based, aka workflow agents, and then of course custom ones. So this is pretty simple, and this is also kind of a pattern that we've seen in the past. LLM agents, okay, we're using them to understand, to reason, to plan, to gen AI responses, and to decide which tools to use, right? The ones that are kind of fine-tuned for tool use. And the workflow agents, well, those are a little bit more rigid, a little bit less, we need an LLM for this, a little bit more if-then, a little bit more predefined and very, very deterministic. Are we doing things in a sequence? Are we doing things in parallel? Are we doing things in a loop? And so this is kind of an interesting idea, this idea of workflow agents. And Wiz, I want to bring you back up to discuss this, because we've discussed this before on this channel, where we've got workflows versus agents. And, it's like this idea of like you have more agency with an agent than you do with a workflow, but typically all applications are going to use both workflows and agents. And now, the ADK is coming in, they're saying, no, it's workflow agents. It's not workflows versus agents. Is this kind of both and workflow agents and LLM-based agents the right way to think about this when we think about, building these applications in general? Do you like this from them?
I mean, like, I don't know, to be honest with you, if I like it.
Yeah.
What I can say is that it's certainly the way they're thinking about it.
Sure.
And it is useful to me, at least, to point to for people who are trying to understand or get an initial intuition for what is honestly a very silly differentiation when we're talking about a continuum, right? Like, obviously people love to bucket, but it is a line that goes from to, and that means that there's every point on the line exists. I would say that the way they think about workflow agents is good, because it helps people to understand that you can still have agentic applications, you can still make agents, even if they are more on rails than other agents. So for people who are very excited about the word agent, this is a big deal. I think for everybody else, this is just one other thing to think about.
Yeah. So like these workflow agents, I mean, are these are these sort of like agentic, or are these just sort of kind of just totally predefined, do it like this? We're just kind of calling it an agent here.
I would say, like, again, agent by itself is unfortunately too big a word for me to possibly succinctly describe this. But the idea is these are still agents, absolutely. They are agentic by nature. At least according to the AIM definition of agent, these are absolutely agents, right? And I think that's the important thing to keep in mind, is that we just have this idea of how structured is the agent, right? It's like a senior engineer versus a junior engineer. Junior engineer comes in, they get their tickets, they do their tickets, they go home, right? Senior engineer comes in, there's a problem that needs solving. It's time to employ agency and autonomy to solve the problem, or describe the tickets that need to be done to solve the problem so the juniors can help fix it, right? This is the idea. But they're both still engineers. We're not going to call them, anything else. And I think it's the same thing for agents, right? Even if it's a more prescribed or described flow, it's still absolutely an agent.
Okay, so it's absolutely an agent. And as you mentioned, sort of according to the way we like to think about agents, as systems that can leverage or emulate reasoning to make dynamic decisions in an application flow. we're still sort of doing this even with something like a workflow agent. Okay, cool. So we've got types of agents. Let's go ahead and move on. Thank you, Wiz, to tool types. And there's just a couple different ones here. Just worth noting that, again, they're trying to be a little bit comprehensive in the agent development kit here. And we're going to get right into the demo here in just a moment. But, you know, the idea is that like tools are kind of everything, you know, quote, what distinguishes capable agents from basic language models is often their effective use of tools. This is from the Google materials. Whether we're doing, you know, reasoning, planning, tool calling, we're doing function calling, you know, we're doing that within that kind of execution space of the event loop, and or whether we're doing some final summary, you know, all of this is kind of leveraging tools, leveraging LLMs, and we might start to bucket these things into some things that are quite common. So of course, we always have third-party tools. We can pull in tools from anybody else's framework. Function tools. So are we putting a specific Python function out there that we want to be able to call totally custom, or, you know, something that's a method or a synchronous function just that we're defining simply? We could use another agent, and that could be a tool. We're literally just function calling another agent as a tool. Or we could also consider RAG as being simply a tool that we're calling, or code execution to be a tool that we're calling. Or, of course, Google is going to give you access to calling Google. Now, the other one here is sort of the long running agent. We've started to dabble in chatting about this a little bit on this channel. This idea of either things that take a really long time, or they're kind of running in the background. And you know, maybe this is just sort of nice to see in there. So, you know, final discussion here before the demo is there anything really new here that we're seeing, or is this kind of just a nice bringing together of the types of tools that generally we're going to see used?
Again, like this is, if I have one main takeaway for people, one main takeaway from people about this whole agent ADK from Google, I think due to the maturity, even though it's not that mature, okay, it's more mature now than it's ever agent space. The docs are a wealth of information about how we think about these things across the board. Like, it's in the Google Docs, but this is the right way to think about these things in LangGraph, in Llama Index, in Pydantic AI, in every other framework that we've ever talked, True AI, right? Like, these docs very well describe a number of concepts that we really care about when building agent applications. And I think that's probably the best thing they've done. So is it new? No. Is it really well described? Yes. Is it a great place to learn about very common patterns that other frameworks have implemented? Yes. So it's all standard table stakes stuff.
Okay.
You know, but it's like really well described. It is digestible. It has been simplified in a useful way across the board. And again, I don't think novelty is where we're at right now. I think we're getting to the space where we're trying to solidify. It's like, you know, Pandas already exists, and we're now trying to figure out how to make it like just easier to use and better. We're not trying to like come up with a new way to think about tabular data. We're just trying to make the ways we think about it really rock solid and easy to use. And of course, you got to say the buzzword: production ready.
Yeah, and standardized.
Yeah,
maybe according to a protocol or two. Okay. Well, let's you can go ahead and stay up here with me. I'm just going to introduce this idea of rolling the dice. This is the build we've got today. And as we can kind of see in our build here, we've got this root agent idea we talked a little bit about earlier. You're going to show us how to get set up, how to build this dice rolling agent, and then build out a team of agents. We've got this kind of cheesy greeting and farewell agent. This was kind of pulled directly and inspired by their docs and the weather bot in their docs. And then we'll show how to sort of track the state. So Wiz, I'm going to hand it off to you for the build today. The dice rolling agent that says hello and farewell. How fancy. Multi-agent with ADK. Wiz, take it away.
Yes. Okay. So this is the good stuff. We will talk about, we'll talk about it. Okay. So first of all, this is the uh, cursor environment. So we're going to use the cursor environment for this. You can use Colab, but I didn't provide pip installs. So just use it locally. It works. It's great. There you go. So basically we have a README here. The README is just going to show you how you run this thing initially, right? So, what you need to make sure you have, and then how to get started. There you go. But again, if you're in a local environment, you just UV sync, and then in the corner, you go to select kernel, Python, and then choose the one with the star, and you're good to go. Okay, so I think Google does a great job describing their own agent development kit, which is to say, it's a Python framework designed to streamline the development of applications powered by large language models. It offers robust building blocks for creating agents that reason, plan, utilize tools, and direct blah, 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 blah. It does the normal stuff, right? But like, this is a great description. I love this description. I think this is, the clarity of language and everything else around this is probably the thing that is most exciting to me. It's just very well done from a documentation, etc. standpoint. Okay, so how do we actually get started? First of all, they have an amazing tutorial that you can follow that goes into some callbacks and guardrails for this example, but we just wanted to modify it, make it AIM style, and describe things a little bit in our own way. And so big old wall of imports. There you go. Big old wall of imports. Love it. And then, of course, many API keys, because you can use many different models. We're going to talk about how to use these different models as we go through. And then we're not going to use Vertex because there's just no reason. Okay, there you go. So now we can set up our model references. You'll notice that this model reference is a little bit different than normal. And the reason why is that we have to use our LiteLLM paths. So instead of having just like GPT 4.1, we have our OpenAI GPT 4.1, and we're addressing the actual version of Claude that we want to use. Now, you may ask yourself, why are we using Claude 3.5 Sonnet? Claude's API is getting absolutely slammered right now. There is no guarantee that it will work for any of their models. So while Claude is on fire, we're basically going to omit it from this notebook. Once it cools down a little bit, I'll add it back. But there you go. Okay. So what we're going to do, we got all of our imports. We set up our models. We're happy. Again, this is going to use LiteLLM as a way to interact with many different model providers. So this is going to standardize the APIs. Basically, this is just to make sure that we don't have to worry about things like, well, how does the API work? It's going to work through LiteLLM, and that's how it works. So we're going to build a dice rolling agent. The reason we're going to build a dice rolling agent is because LLMs are famously bad at random chance. If you haven't seen this before, go to your models and set up some trials of just flipping coins. You'll notice that it is truly terrible at random number generation, which makes it makes a lot of sense, right? So we're not gonna hate them for it or whatever, but that's why we're using a tool for our dice rolling, because we can just import random, which is suffers some a little bit by being pseudo random, but it's close enough, and it's certainly better than the LLM itself. Okay, so a few things to notice, right? Like, these doc strings are important. They're not just doc strings, right? They are instructions, or they are prompts. They help the LLM determine when, how, and why to use a tool, right? So, again, we're taking from other frameworks where the function definition is literally just, or the tool definition is just a Python function. This doc string, right, is how the LLM knows how to call this and when to call this, as well as our pydantic type hinting, which is going to be useful behind the scenes for making sure we're setting the right inputs to the right tools. So otherwise, this is just like straight up Python function, not doing anything interesting. What it's going to do is it's going to roll a D20, which will give us a result between 1 and 20. Well, including those numbers. And then it will add some attribute modifier and proficiency score based on the calling of the tool and the invocation of the tool. So our LLM is going to have to determine what the attribute modifier, proficiency, and difficulty class is from our prompt in order to be able to do this. But we can test to make sure it works by rolling it. We see that error. We did not hit the target. In success, we did hit the target. There you go. You can have a conversation about whether to handle this as an error or not is correct, but that's what we're doing. Deal with it. Okay. Next, we'll create the agent. This is exactly the same pattern that we've seen in many different frameworks across the board. There you go. You know, we name the agent. We give the agent a model. In this case, we're going to use Gemini 2 Flash. We describe the agent, and then we provide instructions for the agent, and then we give it a tool in its tool belt. This is the same pattern we've used across many different frameworks. Classic. It's a banger. Why do anything else? Again, you know, instructions are important here. We want to make sure we're clear and descriptive and concise. And then the description is also important. The reason these things are important is because, like in other frameworks, we can actually delegate these agents or call these agents as we may tools in order to do tasks. And what that means is that we need to know when to call these agents, right, when we're delegating. And this is the way we do that through things like our description and our instructions. Okay, cool. We love that. Next, we're going to set up a session, which is basically our state. And then we're going to set up the runner. The runner is what we've talked about extensively at this point. Again, banger documentation for the runner in their docs. Really great stuff. We're going to use in-memory session, which means that this is just going to be in memory. Obviously, if you want to take this to production, you could use a database or, of course, Vertex if you're deep in the GCP ecosystem. We're going to name our app. We're going to associate it with a user, and we're going to associate it with a session. Already, you can tell that this is application minded, right? We have some user ID, we have some session ID. You can think of trivially how we would extend this to an application where a user has many different sessions and there could be many different users, right? So already we're thinking about how to build this application for many people. The session itself is just stored as this in-memory object again, because we're using in-memory session service. Again, if you wanted to, you can put this in a database and have it persist between, whatever you want. You can control the life cycle of it very, very straightforwardly. But the idea is this is like state, right? So this is going to handle what's happening, what has happened. This is where we're going to make modifications to for this session. This is very important. We'll learn how we can leverage it a little bit more in just a bit. Then we have our runner. The runner is it's like the fancy loop, right? We saw the image of it. This is basically just handling this particular session service and our app, and then it has an association with some agent. There you go. It's going to run the loop for us. So because we're doing this in a notebook, we're going to need to build this helper function, which is just going to call this agent asynchronously. We have some like little print statements to log out here. We have to convert our users' messages into this content type. This content type is going to be useful for interacting with the actual runtime. And then we're, as you've seen many times, instead of .run async, sometimes this says invoke, or sometimes this just says run, or sometimes this says kickoff, right? You can see, though, we're just going to run our runner with this user ID, session ID, and with our content, and then it's going to do all of the agent stuff for us. The way it does this is through this event handling, right? So our runtime does this auto magical event handling, and the basic idea, right, is that our events are how we know what stuff is going on. There are named events that are specific and important that we can look out for, that we can use to do stuff with. There's also something that we're not going to discuss in this notebook, but is discussed in their docs, which is the idea of callbacks as well, which is where we can kind of inject things based on certain things that are happening. And we know those things are happening thanks to the event system. So basically, we just loop through all of these events until we get to the event that is final response. And then from there, we can extract our response and we can provide it to our user. So we're going to do that. We basically call our agent 3 different times on 3 different checks, and we see what happens. Let's see. I want to make a DC 15 check with a modifier of 2 and an attribute score of 3. It puts everything in where it should be, and then it calls it. Great. I have a +4 in dexterity with proficiency. With proficiency, my scrolling is really not working right now. With proficiency, we're just level 1. We get our proficiency equals 2 because we're at level 1. And here we have no proficiency. And so it is 0. Very cool. It does the thing. We're happy about it doing the thing. Good job, agent. Okay, so the next thing we're going to do now we've built one agent is, of course, immediately we're going to build a team of agents. Now, we're going to call these agent teams, but we are going to think of them as hierarchical agents, right? So we have this classic pattern. We build specialized agents that do stuff that's specific. Then we build a router, a manager, orchestrator. Google is going to call this the root agent just for funsies. And then we allow that router to determine which agent handles which task. So let's look at our final graph. Our final graph is pretty straightforward, right? It's just going to be our root agent, which has access to a tool. And then it also has access to a greeting agent as well as a farewell agent, each of which have access to a tool. Now, what's interesting here is that, unlike a hierarchical agent that we would see that is purely a hierarchical, as in this top level agent is just a router, we do have this pattern where we can equip our root agent with tools instead of going to the specialist. So is this entirely useful? Up to you to decide. But the idea is we have 2 actions. We can delegate or we can handle ourselves, and handling ourselves can include tools. Again, this is a hierarchical agent. It's a great pattern. Heck yeah. So how do we build this thing? Well, you know what we're going to have to do, and that's first build our greeting agent and farewell agent equipped with the say hello and say goodbye tools. So what we're going to do is build our say hello tool. It's going to take in a name, and then it's going to say hello to that name. And if there is no name, it's going to say there. So hello there. And then for say goodbye, it's going to say goodbye. Wild. What we're going to do next is build agents for them. These agents are exactly the same as the agents we built before. The only difference here is that we have this LiteLLM model because saying hello and goodbye is a trivial thing to do, right? So we can use GPT 4.1 Nano because we don't need a big model to say hello and goodbye. There you go. We love that. This agent has the say hello tool. This agent has the say goodbye tool. Easy. So now we have our 3 agents. We have our dice rolling agent. We have our hello and goodbye agent. Now what we're going to do is we're going to create a agent team. And the way we're going to do this is we're going to build it as an agent. We're going to copy pasta our instructions and our description, and we're going to add some additional information about when to delegate. So the idea is that this agent now is going to call these other sub agents like tools, right? And we're going to describe this in our instructions. We're also going to, of course, provide it the tool because this is a capability that the core agent has. And you'll notice that we just provide these sub agents exactly like we would tools, in a list format. The only difference is that these are going to be, agents instead of tools. That's it, right? So otherwise, this is the same thing that we did before. Exactly. It is just, has the ability to call both tools as well as calling our friends, the greeting and farewell agent. Okay, so now we can send it requests. Let's send it a number of requests, right? Let's say hello there, thanks, bye, and then try making a check, right? So how do we do this? Well, we can see that when we start this thing up, our hello there is going to be called with tool hello there, and we're going to get the agent response hello. The check is going to be used, is going to use roll to hit, which is going to call on this specific, string, and we're going to get our roll back. And then our buy, prompt is going to call the buy tool. You can't make it up. It works. Again, this is handled through that delegation process. So when we get this process, our actual, or this query, our actual main agent is not calling say hello. It's delegating to another agent, which is going to call say hello. And then say hello is going to be invoked by the agent. It's going to propagate up to the top, and we're going to return it as an event. And then we're going to parse it out, and we're going to get that response. So this is dope, but stateless. We don't love that, so we're going to add state. Adding state is very straightforward. We simply add state. So when we set up our initial state, we include the initial state. That's it in this object, right? So basically, every time we want to start with some state, we can just inject it in this initial state, and there you go. So we take our session, we add state to it, boom. There's no more to it than that. We can actually get our session, and then we can look at our session state, right? So in this case, we're going to have this user advantage true, right? So they have advantage, and we can see that this advantage is present in our initial state. There you go. I mean, this is as easy as it gets, right? Just like with other frameworks, we can set up our state to be arbitrary, whatever we want. But when we key into our state, we have to remember how we set it up and what's been put there. So this is how we're going to leverage state. You'll notice that in this definition, right, this function, we just add tool context. Now, tool context, what it's going to do is it's going to be able to pull context for this tool through state. So what does that mean? It means that we have access to our state that we set up for our session through this tool context object, which is very important, right? Because the whole point of state is that we really want to be able to determine if or if not this state is useful, and we want to be able to have conditional logic based on our state, right? So in this case, again, we pass in this additional tool context, and our agent is going to handle this automatically for us, right? We pass in tool context. It's going to be able to key into state. Then we can get our user's advantage. We set a default just so that the tool doesn't spin out if it can't find that state object. And then we have this conditional logic, which is advantage in the system. Dungeons and Dragons 5e advantage means you roll instead of 1d20, 2d20s, and you keep the highest. So we've added this conditional logic here based on the state. That's it, right? That's how we think about state. It is something that our tools and our agents have access to and can modify, and therefore can change the way the application is working as we go through this flow. Finally, we can make our team, and our team is going to be the same as before, except in our final definition for this agent, we're going to include the stateful tool, and we're also going to automatically save the last roll result. This is just a helpful thing to be able to do, which is basically our final output key for this agent is going to be called last roll result. So when we use this key, we're going to get the final result, which can be very useful. Finally, of course, we have our runner. The only thing we do is make sure that we're using our stateful service, right? Or else we wouldn't do anything. And then here we can do this, right? We can run our agent with this query, and then we can pass in our stateful sessions and everything. And then we can see, right, what we get. Then we can update our state. And updating our state, right, is just going to involve loading our session and then manipulating the state. So before this was true, now it's false. Boom, done. Then we call the agent, and then finally we call it with a new query that says hi. And the new query that says hi is just to make sure we're still able to access that hello agent. When we finally call this, we can print everything out, and we can see that indeed, when we did our first our roll, you know what I mean? We got this state was user advantage is equal to true, which means we rolled with advantage. In the second one, we got user advantage is equal to false, and so we rolled without advantage. That's it, right? That's the idea. We just set state, then we can consume state. We can modify state in the flow of the agent, right? We don't have to like restart or reinitialize the agent. We can actually modify state as we go through, and that's what helps us build that agentic pattern. And then finally, we can use the final session state, right, which is going to give us from this output key, hello there, which is indeed our final sessions response. There you go. That's how we do agents with Google ADK. It is what we know and love. If you've used other agent frameworks, it's going to feel very familiar. And again, the whole idea here is that we have this ability to do what we've done before, but through Google's ecosystem that it's coupled tightly to. Can't say much more about it than that. Okay. With that, I'm going to pass you guys back to Greg. But before I do, I'm going to ask you to subscribe, like the video, click the little bell notification. We're here every Wednesday, rain or shine, whether we're at a conference or not. We're going to be here. And so with that, back to Greg.
Yes. Okay. Thank you, Wiz. So we got a great question in the chat asking about deployment, and I want to go ahead and address this question from Rama. So if you were going to go ahead and deploy this, you specifically, I think, wanting to see you deploy it on the Vertex AI agent engine, how would you recommend deploying this in general if you wanted to sort of get this out there to the world?
I mean, like, you can do it however you want, right? So if you want to just like, quote unquote, one click deploy it,
one click.
You can go to things like Vertex and Cloud Run. But like, because you can, run this in a Docker file, you can deploy wherever you want. The idea is like, if one click deploy, obviously Google services are going to be very, very easy. This is the preferred path to deploy. It is easy to do. It is like, it's just very easy to do. Like, it's like, we could bring up the code, but it's basically nothing. And that's the benefit, right, of being tightly coupled to a CSP. But if you just don't want to do that, and instead you want to use push this somewhere else, obviously you're going to have to build a Docker container to do that, and that's going to be slightly more effort on your end.
All right. Well, thank you, Wiz. Let's go ahead and just introduce this last little bit that we can have a discussion about. So let's talk about the protocols that everybody's talking about real quick. And this is again from the Google Docs. We've talked about MCP recently on this channel, but MCP follows a client server architecture. Very, very important to understand, defining how data, resources, interactive templates, prompts, and actionable functions tools are exposed by an MCP server and consumed by an MCP client, which could be an LLM host application or AI agent. So we can either expose or consume using MCP. There's two ways to use this with ADK, and they outline this quite well in the docs. Using existing MCP servers within ADK, this is probably the much more prevalent way people are going to leverage this, or exposing ADK tools via an MCP server. So in the first case, the ADK agent is going to act as an MCP client. And in the second case, we're going to make ADK tools accessible to other MCP clients. One more layer I want to put on here. This is sort of a trailhead for next week a little bit. We're lacking an image here, but the agent-to-agent protocol also put out by Google addresses a critical challenge, that agents need to communicate as agents, not just as tools. So this idea of providing this common language. And this image was going around LinkedIn this week. There's also a reference not showing up on this slide. Shout out to Rakesh, who put this out there. And, I think it's important to note here that when we see something like Google's ADK, we're actually leveraging and sort of being the client of these MCP servers right here. And, agent to agent protocol sort of sits atop communication without sharing each other's data. We could imagine building a LangGraph agent, building a Google ADK agent. And, Wiz, I want to just bring you up for this to sort of start the discussion and QA here. This is a fun image, of course, as we think about using ADK with MCP, with A to A. Is this something that you see people should be trying to figure out right now? Is this something that we're going to be commonly leveraging as like a setup like this, or sticking within building single agents, maybe just consuming MCP servers? Maybe that's sort of a great place for people to start.
I mean, yeah, like you definitely could build this system. I wouldn't start here, obviously. Like this is a grossly overcomplicated mess for most applications. But
right.
if you find yourself needing to, you could push into this and you could get this going and done. And I think that would be that would be dope. It's less like should and more like could,
Yeah. Very, very cool. Okay, so I also want to just mention we are going to be covering A to A in much greater detail next week, so join us for that one. Today what we kind of saw is we saw a similar thing that we saw with the Agents SDK from OpenAI. The ADK is pretty good. The event loop, although it might not be that novel, is very well described, as were many things in the docs. This is a competitor. Perhaps the best part was the docs. We are seeing a bit of a maturity in the industry, a bit of a feature parity across different frameworks, leading frameworks. And with that, we've got a few questions related to that, Wiz. First, I'd like to go to Rajat's question. So is it still LangGraph that we prefer here, or is it ADK because it's just so good?
No, LangGraph still we prefer. I mean, it's like none of these frameworks are bad.
Yeah.
So if you're just like, if you love ADK and you watch this and you're like, I vibe with that, man. I love that. That tickles me. Then it's great. That's a great framework to use. But if you're just asking, you don't have a strong opinion about which one you prefer to look at and use, then we're going to continue to recommend LangGraph until something dethrones it.
Okay, so Black Current, one of the Weekly Wednesday legends here. How would you evaluate this given the framework here? How would you use the built-in evaluation tools? Maybe for people that have seen other evaluation tools we've shown before.
Yeah, I mean, they have a whole section on evaluations. The evaluations are like kind of, I don't know. They're working on them. That's for sure. It's the same kind of style as, LangGraph. The thing that I like about it, if you, I'll just link this in the chat. But like the thing I like about it is this idea where you can have like a trajectory it's supposed to have, or a trajectory that's most optimal. This is useful. You can provide it as a ground truth and see if it does that, right? So this is great for workflows, especially. But the idea is like, if for a given request, it should search this, then do this, then do that, then do this, then do that. You can provide that and see if it does, see if it gets close, and evaluate based on that. But otherwise, I would say the evaluation is like not. The agent evaluation is being worked on across the board right now, and I would say while it is dope, it has a long way to go.
Yeah. Okay. And finally, Rainbow wants an order ranking. Can we get an order ranking here going? LangGraph, Llama Index, OpenAI, SDK, Pydantic AI.
Yeah. I'll just provide an arbitrary ranking of these.
Yeah. Please do. The people want it. Everybody wants to know.
What are the options? What are we pulling from?
Yeah. So LangGraph
for sure first. Pydantic second. ADK third. Llama Index fourth.
Yeah. Okay.
OpenAI agents taking
OpenAI agents
the L
taking.
on this one.
Okay, wow. Okay, following up. Okay, excellent. Well, thank you for your insights and your wisdom today, Wiz. Appreciate it. It's time to wrap up, and thank you everybody for joining us. We'll see you next time, Wiz. And thank you everybody for joining us for the ADK Agent Development Kit from Google. I want to invite all of you, if you haven't checked out the Discord yet, hop on in there and start building, shipping, and sharing with all of the local legends that are in there every week building production grade LLM applications. It's a great place to start learning, building, shipping, and sharing for free. Also, if you want to go ahead and join us next week to keep the discussion going about Google's ecosystem, protocols, and agent frameworks, we're going to go deep dive on A2A or agent to agent protocol. That should be a fun one. We've also got a couple of other events coming up next week, including an MCP and A2A overview that we're doing and hosting in Zoom. This is a Maven Lightning lesson. I encourage you guys to check that out as well on Tuesday. And on Thursday, we've got our demo day for cohort 6 of the AI Engineering Bootcamp. If you're considering accelerating your LLM application development as an individual or a team leader, you might want to come check this out. And we've got our upcoming cohort 7 launching June 24th in just a few weeks. We've got a price increase coming with our flagship product, the AI Engineering Bootcamp, at the end of this week. So if you want to get in and secure your seat, now is the perfect time. 10 weeks, and we'll bring you all the way up to the LLM edge, get you building and shipping and sharing like an absolute legend in 2025. And with that, thanks again for joining us. We really look forward to seeing you again next week when we talk A2A. And until next time, keep building, shipping, and sharing, and we'll do the same. See you soon, everybody.